Hello students, we have learned the concept of motion and rest. Today we are going to study about the physical quantities. They are speed, velocity, acceleration, time, volume, area, all these are the physical quantities. And now we can define physical quantities as all those quantities which can be measured directly or indirectly and in terms of which the laws of physics can be expressed. How we will express the laws of physics in terms of acceleration, mass, velocity, we will see later on. First, let us define it. Physical quantities. All those quantities which can be measured directly or indirectly and in terms of which laws of physics can be expressed are called physical quantities. Examples: time, volume, displacement, distance traveled, speed, velocity, acceleration, etc. On the basis of magnitude and direction of physical quantities, these physical quantities are divided into two groups: scalar quantities and vector quantities. Scalar quantities are those physical quantities which only require magnitude for its complete description. For example, you take speed. When we say a vehicle is going on the road with a speed of 10 km per hour. Here 10 km is magnitude of the speed. Only we concerned with this 10 km in case of a speed. When we have to say in which direction it is going, then another physical quantity will come here. So only magnitude we require. In case of volume, you say only the magnitude. The volume of a cube is 30 centimeter cube. Here 30 is the magnitude. So in case of physical quantities, we require only magnitude for its description, for their analysis, or to add them, to multiply them, etc. Let us see what is the scalar quantity.
Play.
Scalar quantities. all those physical quantities which require only magnitude for their complete description are called scalar quantities. Here you have to pay attention. They have only magnitude. They have not description. Sorry, direction. For example, volume, time, distance traveled, work, power, etc. The second physical quantity is vector quantity. All those physical quantities which require both direction and magnitude. Those physical quantities are categorized under vector quantity. For example, when you will say a car is going with 40 km per hour towards north. Here the 40 km is per hour means 40 is the magnitude, and towards the direction is towards the north is its direction. It is very important to say in which direction the vehicle is going. In case of displacement also, when a body is displaced by the external force or itself, when it goes from this place to another place, in which direction it is displaced is important to say. Such type of physical quantities are categorized under the vector quantities. In later on, when you will study in standard 9 or 10 or 11, 12, you will see some physical quantities also comes which have direction, but they are not vector quantities. For example, current, electric current, already I think you have studied in standard 8. Electric current have its special direction, conventional direction of electric current, but electric current is a scalar quantity. It is not vector. Law for their multiplication, vector product, scalar product, and these laws you will study in your higher classes. Only you listen, only you keep in your mind. There are different laws for addition and multiplication of vectors. Examples are displacement, velocity, force, momentum, etc. Now, let us learn different physical quantities related to motion. And first, distance traveled. The total path length covered by a body is called distance traveled. It is a scalar quantity. Look on the blackboard. A person starts from here. And he follows the path like this and reaches to his house. This path, A to B, then C to D, E, F. The total path length will be AB plus BC plus CD plus DE plus EF. This total path length is called distance traveled. Now, displacement. Displacement. The shortest distance between the initial position and the final position of a body is called displacement. The shortest distance between the initial position and the final position of a body is called displacement. And what will be the shortest distance? The straight line, because the straight line is the shortest distance between any 2 points. So the displacement will be the straight line between the initial position and the final position of a body. Here you see in the example. This is distance traveled. And this is displacement. Means direct AF is displacement of this person from A to F, from its initial position to the final position. Now, vector displacement is a vector quantity. It is a vector quantity. discuss a numerical which will clear your concept of distance traveled and displacement. Look on the blackboard. Find out the distance traveled and displacement when a body is moving on a circular path of radius r. First, find out the distance traveled and displacement when a body is moving on a circular path of radius r, when it covers one complete revolution second, half revolution, and third, 1/4 of revolution. This is the circle of radius r. Now for the first case, when it covers one complete revolution. First, distance traveled. Distance traveled. Distance traveled is total path length traveled by a person. So, when it will complete its one revolution, suppose it starts from here and it will come back to here. So, the total path length will be what? The circumference of this circle. So, the distance traveled will be 2 pi r. Now, see the displacement. As body starts from here and come back to here, so displacement will be what? Displacement will be 0. In the first case, the distance traveled is 2 pi r, that is the circumference of the circle, and displacement is 0 because body starts from here and comes back to here. So the displacement is 0. Let us see the second part of this question. Second part of this numerical is when body completes half revolution, means it starts from here A, and after completing half revolution it comes to this point, means half of its circumference. In this case, the distance traveled will be what? pi r by 2, half of the circumference. Finally, pi r. Now what is the displacement? Displacement is the shortest distance between the initial position and the final position. And the shortest distance between A and B is the straight line joining A and B, and this line is the diameter of the circle. So the displacement in this case will be 2r, 2 times of the radius. Now let us see the third case. 1/2 of a revolution. In this case, the distance traveled will be what? 1/4 of the circumference. Two pi r by 4, that is pi r by 2, and this displacement will be like this. It goes from here to here, and the shortest distance will be this AC, and to find out AC you have to join this like this. This is O, this is the center of the circle O. We are having a right angle triangle, and to find out AC we have to use Pythagoras law. AC square is equal to AO square plus CO square, R square plus R square two R square, and finally AC is equal to root under 2r square. The answer will be root 2r. This is the displacement in the third case. Now we can conclude when a body is moved by a distance it can have zero displacement. This is the case of numericals first question A. In case of A, when a body completes one complete revolution, displacement is 0, whereas distance traveled is 2 pi r. Let us discuss another example to understand distance traveled and displacement. Look on the board here. Suppose Ram is traveling from A to B, and the distance between A and B is 100 meters. In this case, the distance traveled is equal to 100 meters. and displacement is also equal to 100 meter. Magnitude, only magnitude we are discussing. A to B, from A to B, but the magnitude of distance travel is 100 meter and displacement is also 100 meter because Ram is traveling along the same direction on the same path. Now see the another situation for the Ram. Now Ram is starting from A moves to B and further moves along the same path to the C. This distance is 100 meter. This distance is 50 meter. Now Ram changed his path. In the third case, Ram changed his path. He moved from A to B and turned back on the same path to C dash. B and to C dash. This distance is 100 meter and this distance is 50 meter. In this case, the distance traveled and displacement will be same. But here, when he turned back, when he changed his direction, then the displacement is is 50 meter, although the distance travel is same, 150 meter, because he travels from A to B and B to C dash. This is 100 plus 50. Then distance travel (100 plus 50). So even then he has changed his direction. The distance travel is 150 and 150. But when he changed his direction, he is going in the same direction further, and here he returned back on the same path. The displacement has been changed. So what we conclude? We conclude when a body travels along a same path in the same direction, then the magnitude of displacement and distance travel will be equal. Otherwise, distance traveled may be greater than or equal to the displacement. Now we can conclude that when a body travels along a straight path in the same direction, then the magnitude of displacement and distance traveled will be equal. Otherwise, distance traveled may be greater than or equal to the magnitude of displacement.